I created many videos on YouTube about how self in Python works. But each year I learn more about Python and I dive a bit deeper, so it's time for a deep dive video. Now, I'm a big fan of Python's documentation, and for every video on self I used this as reference. The key to self in Python can be found here. Now, if you want to read it, pause the video, but I'm going to paraphrase what is written here. Employee is an instance. When you access an instance attribute, Python checks if it is a function. If so, Python creates a method object with a reference to the instance and the function. When the method object is called, a new argument list is made by inserting the employee instance as first value. The method object has a reference to the raise salary function and calls it with the new argument list. Now, this is perfectly good information, but there are two important pieces missing. First of all, the documentation says that a method object is created when the attribute is a valid, non-data, callable object, aka a function. Second of all, it says when the method object is called. But who does the calling? Spoiler, you do. To explain how all that works, let me show you some code. Here is class employee that takes a name and salary. It has method raise salary that takes a factor and bonus. I create an employee and raise the salary. No surprises here. Let me look into the employee object. I see the data attributes and the function. Now, even if the dir function shows all attributes, there is a big difference between them. Raise salary is a reference to the function in class employee and is shared across all employee instances. Attributes name and salary are instance variables that will be unique for each instance. But the big question remains: how can raise salary be called with 2 arguments, while the raise salary function takes 3 parameters? Let's see what raise salary is. That is interesting. Raise salary is not a function, it is a bound method. So what is raise salary when I access it directly from the class? That is a function. So what does the instance do that turns the function into a bound method? Notice so far I did not call raise salary. All I did was access it through an attribute and saw this output. You probably have seen it yourself 1,000 times when you forgot to type the round brackets. But why does the instance attribute return something else than when I access it directly on the class? Well, let's dive in deep. I'll compare accessing raise salary from instance E1 and from the class employee. For instances, Python calls tpgetAttro on the type of the instance, which is the class employee. For classes, tpgetAttro is called on the type of the class, which is type. All of this happens inside CPython and is not directly visible at the Python level. Now, tpgetAttro is not a function itself, but a function pointer. For instances, it points to PyObject generic getAttr, and for classes, it points to type getAttro. These functions implement attribute access. Both functions start by looking up the attribute. Through slightly different paths, they eventually find the raise salary function object in the class. Then they check whether the object is a descriptor, which means checking whether it implements the dunder-get protocol. It then assigns the function descriptor to tp_description_get. The instance implementation then calls the descriptor with 3 arguments: the descriptor itself, the instance, and the owner, which is class employee. In the class case, the descriptor is called with null instead of an instance. Finally, inside func_descriptor_get, this difference determines the result. If the instance is null, the original function is returned. If the instance is not null, a method object is created by combining the function and the instance. And it is this method object that calls the class function with the instance as first argument. But I'll come back to that soon. It is actually funny when students of my OOP for Beginners course want to know how self works. I usually answer, all you need to know is that Python passes the instance automatically. And then I just hope they stop asking questions. Well, you probably understand why. It is a concept that is easy to use but very hard to explain. The crux to the whole story is that when I accessed Ray's salary on an instance, Python intercepted, and instead of returning the function, it returned a method object. For this, it uses something called a descriptor. And even if all of this happens in C Python and is out of our control, the code follows the Python descriptor protocol, and I can emulate this behavior in a regular Python class. Would you like to see that? It would give you a pretty good idea how descriptors work. Let me show you. Before I create a descriptor myself, let me show you that the raise salary function is already one. Look at this special method. When an object that implements it is assigned to an attribute and that attribute is accessed, instead of just returning the object, $get will be called and you can intercept. You can perform checks, calculate values, and even return a completely different object, like a method object. I will use that fact by rebuilding a function with a custom class. Now perhaps you know that functions in Python are objects that implement $call. I know it looks strange that a function gets self and instance as first parameters, but stay with me. I'm just writing this code to emulate built-in behavior. Instead of defining the function in the class, I assign an instance of raisSalaryFunc to a class attribute. What happens when I access this attribute from an instance? The attribute has a reference to the raisSalary function, but that is not what I want. When I access raisSalary, it should return a method object. I'll create a method object class. Instances of this class have a reference to the function and to the instance. When I call the method object, I call the function with the instance inserted as first argument. Now I make the function a descriptor. Okay, what happens if I run the code again? Very nice. The descriptor returned a bound method that has a reference to both the function and the instance. It is ready to be called. The code editor is a bit confused about the missing parameter, but at runtime everything will work just fine. Very nice. What if I access raisSalary from the class? I get the function, not a bound method. Now, of course, you should not replicate this code. It is just to demonstrate how Python does things in the background. Everything you see here is implemented much more efficiently in CPython. But if you're going to remember one thing about this code, let it be how descriptors can intercept attribute access in Python. You can use this to return calculated values or completely different objects. Descriptors can also be used to intercept when setting or deleting attributes. You can easily see how this can be used by things like the property decorator. Now, I'm not a fan of such techniques as they obfuscate code. That is why you will not find them in my code on this channel. But it is my job to show you what is possible and you decide for yourself what is best for your code. Now, there was one thing in the documentation I want to come back to. It says when the method object is called. So who calls it? Well, since the descriptor returned a bound method object that is callable, you do. Now, if you like such deep dives into the internals of Python, check out my course on magic methods in Python. There you learn how to design classes that integrate seamlessly with the Python language. A link is in the description.